Welcome. My name is Adrian Sorsby. I'm the Field Sales Manager for Balluff. Been with Balluff for around 16 years, and I've been present in the world of hydraulics as my other role as Product and Marketing Manager for our measurement products. So it's given me a lot of insight into all the different applications in hydraulics. We're really proud to have been working with John here at the NFPC, and delighted he's invited us to give a technical lecture here today. Just what we'll run through. First of all, if I may, I'm just going to spend a few minutes just talking about Balluff, just to set the scene, just to let you know what we do, where we come from. I then want to talk about position feedback for your application, why you might be using it. Then spend some time just looking at the different types of technologies which are out there, internal, external to the hydraulic actuator and around the automation in hydraulics. And then spend some time looking at the applications, which are wide ranging, and I'm sure some of you will find some of these applications fall into your industries. So Balluff, we are pushing on 3,000 people, 335 million euros turnover, 59 subsidiaries around the world. We're based 9 production sites around the world, but our HQ is based in Stuttgart. We're a German company, and but we have centres for excellence for manufacturing all the different products around the world. Some factories specialise in the miniature, some factories specialise in different product technologies. Just a quick slide showing, just because we are a family-owned company, something we're very proud of at Balluff. We're still family-owned. We're a 4th generation family-owned company. It's important to us. It just comes through in the values in everything we do, the ethos of how we do business, from how we look after our employees, from the training we do, how we interact with our customers, develop the products, and the long-term relationships we have with our customers. So Balluff started in 1921. The first generation, Mr. Balluff, he started manufacturing the noodle press. That was the first thing he did. Many developments since then, and through 90 years, factory automation, industrial automation is what we're involved with now. So after noodle pressures, bikes, shops he did, but then it was sort of 50 years ago we started manufacturing the first electrical and mechanical technologies, and that's when we first started applying for patents on inductive technologies, mechanical technologies. We started making the first remote sensor systems. This is power and signal across an air gap, a technology which Balluff's very proud of, and with this in the case there, and some of in the foyer, some of the demonstration rigs, you can see some of that technology there. Right up to this particular product is one of our RFID products, of which we've won many awards. Red Dot Design Awards is something that we won for that, and that's a design award we're awarded across the whole industry. So that's people making kitchens, consumer goods, so it's a design technology award. So again, something Balluff are very proud of. Now I mentioned also our HQ is Stuttgart. That's where all of our R&D takes place, and we're also an accredited test house there. So we get lots of competitors' products and other industrial companies come to test their products at our test house. We also, when we're developing products, we go through what we call HALT testing. So that's high accelerated lifetime testing, and that means we can take a product, we can rattle it, shake it, we can heat it up, cool it down, and we can break it in hours a day. So we break the product and then we take it out and say, look, the component X has failed. Let's find a new manufacturer or a different way of putting that component on there. Test it again. It will last for a few hours longer. Doesn't mean we offer different warranties. It just means intrinsically the way that we develop our products is the best it can be. And just before we get onto the hydraulic side, we have a massive range of products. We fall into business units: object detection, that's the inductors, mechanical, capacitive, ultrasonic sensors I mentioned. The block at the top there is from our networking department, and with the IO-Link system, which we've now got, which you can see again in the case and the stuff out in the foyer, we've really started to make inroads into factory automation in the last few years. Really changing the way people automate the factories and moving towards a more smart factory. And something we can chat about afterwards, after the presentation, if it's of interest. RFID systems, again, when we started doing these 30 years ago, particularly in machine tools, we started out, really changed the way that machine tools and CNC machining was done. An overview of just a couple of products which we get involved with more into the hydraulics industry. pressure sensors, pressure transmitters, fill levels for power packs, accumulators, capacitive sensors. We have a technology on a capacitive sensor called Smart Level, which has got a patent on it. What this does, the sensor will ignore foaming in a tank and only give a true level output, and also ignore dirt and build up on the sensor front face, so not give any false readings. And then we get involved in sensors and transducers inside cylinders, transducers in the cylinder, sensors for detecting piston end stops, soft stops, spool and valve controlling as well. And it's taken us into a massive array of applications, which we'll get onto later, but as a snapshot from the opening ceremony of the Olympic Games, we're involved in projects for lots of lifting and moving hydraulic equipment there. Machines working on the seabed, machines working out on the ocean, refineries, petrochem plants, turbines, we've got our products in there. And also lots of really interesting applications, such as, does anybody know what this thing here is in the snow? This is it's quite a few years old now, this application, but it's I believe it's the Heli 6 British Geographical Survey laboratories in the North or South Pole, I can't quite remember which, but out in the snow. And there's a hydraulic cylinder with one of our transducers on each one of these legs. And essentially when they want to move it, or the snow's too high, as I understand, they wind the legs up, make sure they're all at the right position, and they can tow the lab off somewhere else. So into our world of hydraulics, there's automation all around, it's increasing all the time. Personally, we get involved in all areas except, I suppose we stop at the PLC, so from the PLC downwards. But the sensor switches and automation in the panel, in the accumulators, in the power packs, in the valves, and also in the hydraulic actuators. So I just want to focus now on the hydraulic actuator area and just talk about some of the positioning technology around that. Why do we need to know where our actuator is? The same as any automation trends, we need to do things faster, we need higher accuracy, we need less downtime, better production rates. Therefore we need to monitor all the way along the cylinder what's happening, where is our position. So quite often just as it open or close is not good enough in the world of automation these days. So linear feedback generally falls into three fields. So we've got to control linear motion, which is closed loop control, such as say a flight simulator, or something like this, where you need to move it fast, slow it down, move it again. And when you're selecting a sensor for this application on the hydraulic cylinder, speed and accuracy is the most important thing which you need. The next area, and this I think is where the bulk of hydraulic actuators fall into for position feedback, would be monitoring linear position. Monitoring the position of a cylinder. Did it get there? Has it come all the way back? And an infinitely variable proximity switch, if you like, on a hydraulic cylinder. The most important factor we need to consider here is repeat accuracy on the sensor which we select. And finally, to make measurements with our cylinder. So we need, the actuator needs to measure where we are, whether we're profiling something, doing a cut to length measurement, and in the device we select here, the most important thing is the linearity of the device. So the accuracy needs to have high linearity on there. So they're often different in different devices you might select. So we've talked about the accuracy. Environmental factors may seem obvious, but there's so many considerations we have to take into account. Some images here, civil engineering. Is it out in all sorts of weather? Is it underwater? Is it seawater? Temperature, am I in a steel mill? Am I like the previous picture, are we out in the snow? Is it on a power press, being rattled, shake, on a train? Access to the device itself. Do I need to get to it? Do I need to change it? Do I need to maintain it? How big does it need to be? Is it a fit and forget device? Do I need to service the device? So on the hydraulic cylinder, generally we can, for a transducer, we can sense internal or external. So if we're internal, let's find a transducer. So this is just one of our position devices. So in the image here on the right, we've got a transducer in a cutaway of a hydraulic cylinder. So we would have a magnet element bolted to the back of the piston, and as it moves up and down the rod, we've got a gun drill hole down the cylinder, we get some position feedback. And I think from the environmental considerations, if we're starting a project afresh, time, money isn't a problem, I think we'd always put a transducer inside the cylinder. It's the best packaging I think we can have. But many times you can't do that, so retrofit applications, so there's many products on the market which you can mount external, such as the ones on here, so you could piggyback that on the outside of a hydraulic cylinder. Just a little bit more into cylinder feedback systems. We discussed internal devices, and we'll discuss the technologies next, but magnetostrictive, potentiometers and LVDTs, these are some of the popular technologies for position feedback on a cylinder. Not exhaustive, but some of the popular ones. For longer stroke cylinders, 10 metres plus, telescopic cylinders, there's lots of the cylinder manufacturers have developed their own particular measuring systems. Limit switches on a cylinder, so we could have an inductive sensor. So this is just detecting metal, detecting the piston as it comes along. We've got a pressure seal and a high pressure front face on here just to detect the cylinder position. We could also have the inductive sensor external to the cylinder, just picking up on flag as it moves by, or this could be a mechanical limit switch mounted external. I'm probably down to the lower cost cylinders, probably use smaller, more compact, used more in the mobile agricultural market. In recent years, these have probably had no feedback on whatsoever, but I think that's changing. Certainly in the last year or so, we've been involved in more and more inquiries to get position feedback sensors in there. But it's very expensive to do for a mobile cylinder. You've got to gun drill the cylinder and get the transducer in. Balluff are working on new technologies here to put into hydraulic cylinders for the mobile market. And hopefully if you're back here next year, we'll be able to chat about that technology. So quickly just on to the different technologies that we get involved with in hydraulic actuator control. The first one, linear potentiometers. These are at the lower end price segment of the market. Analog output devices, lower accuracy, and it says they're less reliable. Depends what application you're using them for, but because it's a contact device, in some applications they will wear out. So how they work is we've got a fixed resistive strip of a known resistance, voltage across it, and then the wiper, the position element, moves up and down this strip, and obviously at one end there'll be a greater resistance or lesser resistance at the other end, giving a proportional output. So some applications are great, but say on an injection moulding machine, for example, if you're in 24/7 back forth to the same part all day long, there's the potential for that to wear out in that one zone. Next technology to talk about is LVDTs, and this LVDT is sometimes a term people use to describe any position feedback device, but it's actually a technology in its own right, linear variable differential transformer. So as the name suggests, it's a transformer, voltage in the primary windings, then we have a ferrite core moving in and out, induces a different output, voltage output on the secondary windings there. And basically how far the core moves in and out gives us a different output. This device is a non-contact device. It's better on vibrations than potentiometers, better on temperatures. But along with the potentiometer, because it's inherently a voltage device, that's all you get out of it. So if you want any other sort of signal, you've got to do extra signal conditioning on there. Moving on now to magnetostrictive sensors. Again, these are non-contact like the LVDTs. We can get much more higher accuracies out of these devices, and I'll explain how they work, but because it's a digital signal that comes out of them, the manufacturers generally have onboard signal processing to change it to an analog, a digital, field bus, any sort of interface you want. And they're usually at least IP67. So how do they work? They've got, on their inside each transducer, we've got a magnetostrictive device, we've got a waveguide, and looks like this. And down the centre of this waveguide there's a thin copper wire down there. And as you can see from the animation, essentially we have a current pulse, which initiates a electromagnetic wave that moves up and down this rod. The position marker, the magnet, interferes with this wave and then creates what we call a strain wave. One of it, with this wave is bounced up and damped at one end, represented by the blue here. The other end, it comes back down to our electronics. The time we send out our start pulse to the time it takes this strain wave to get back is proportional to the distance, as in a time flight sensor. So that's how the magnetostrictive devices work. Just briefly, just look at the outputs from position feedback devices on hydraulic actuators. Analog is still by far the most common. It's for obvious reasons. People know what it is. We can buy analog interface cards from widely available. But there are limitations to it. For example, one limitation on a popular signal is 4 to 20 milliamps. You've got 16 milliamps to divide up across the stroke of your transducer. So the longer transducer you've got, you're going to have 1, 2, 4, 5 meters. You're going to get less resolution. Different sort of interfaces we've got. So for high in motion, lots of people are using SSI, serial synchronous interface, digital outputs, and then analog interfaces for low in motion. It says on this slide tomorrow's preferred interfaces, but certainly from our experience, the future's here on this slide. We've got lots of customers talking to us about Ethernet-based systems for high in motion control. And then down at medium and low end positioning, we've got more customers talking to us about moving from analog to digital field bus systems or iLink systems. And the iLink systems I just mentioned earlier on, I suppose it's certainly from Balluff point of view, it's helping us contribute towards what the industry is talking about as Industry 4.0, which is the coining as, I think it's a German led phrase, but coined as the fourth industrial revolution, starting being steam the first and the electrical devices, digital revolution, and then now software and smart, the fourth generation of how can we get autonomous machines, develop software and get really smart factories. And certainly iLink is helping us do that because it's allowing easy connections, remote diagnostics and remote setups from some of our components. And that's a quick example of how it would be in the hydraulics, and we've worked on some real projects in the last 12 months where we've used our iLink systems, and it's just with a field bus system at the top. The iLink allows us a 3-wire point-to-point communication system to sensors, actuators, indicators, components in the panel, and it's just allowing us to step even further towards the smart factory. So if I can now, I just want to go through a few applications. Hopefully there'll be something relevant to everyone here. Renewable energy, wind power. Personally for us at Balluff, it's something we've been involved in since the infancy of wind power. Just a few applications. Hydraulic pitch control. Most hydraulic pitch control turbines you see out there will have a Balluff transducer in there. 3 in each turbine controlling the pitch of the blades to slow it down and speed it up. Sensors for rotor, lock position so you can stop the turbine securely to make sure people can get in for servicing. That's an image of a Kaplan turbine in hydro turbines. Position control there. Inclination sensors and rotary encoders we've used for solar plants. So such as in the image on the wall there. It's each one of those solar and discs has to be orientated to get it in the correct orientation, and there's an encoder product at the bottom of each one of those. Conventional power generation, there's hydraulic cylinders with feedback on damper controls, diverters, valves. And in oil and gas, pipe handling and lots of valves again, and again personally from a Balluff point of view we've been involved in with lots of linear actuator manufacturers selecting our products, particularly because of all of the ATEX approvals we've got. The technology is magnetostrictive, so it's a fit and forget device, and the wide range of temperatures, because we've got applications, petrochem plants in pipelines in the jungle, in the snowy environments as in the image we saw before. And also offshore as well. Tensioning cylinders, wireline tensioners, controlling risers against the flow and motion of the sea. I'm just looking now into the steel industry. Lots of applications for hydraulic actuators, position control. The cylinders controlling and the width of the garb's edge guidance on there, continuous casting lines. Most automated casting lines these days will have 4 hydraulic cylinders with feedback on there, controlling the segment, how much essentially it squishes and squashes the continuous casting process as it moves down the line. Casting ladles, setting roll gap on mill stands and so forth, this all needs to be controlled remotely. Personally, we've been successful on some of these projects because of the temperature the transducer is going to go up to, and also by using our rapid replacement module in heavy industry is very useful. So here's an example of our standard industrial transducer, which we took apart earlier. But should there be a problem with it, just 2 bolts out of the back, we can take the electronics head off, just disconnect the wire, and then we can replace the electronics head. Should there be a failure, or should it get more than likely bashed or something like this. And this is important because these transducers can be 7-8 metres long. So in a hydraulic cylinder, that's a lot of clearance we need to get the device out. So if we can just remove this part and leave that in the cylinder, so it's a very useful device to have. Into factory automation, again hydraulics present in factory automation. Position devices, automotive plants, tyre curing presses and the vulcanising process, that you need very accurate control of the presses. Shut-height, height protection, measurement on metal forming. Again, we've been selected on some of these projects because of the vibration ratings we can withstand. Ship building and products on ships. On ships, there's stabilisers on most ships these days, so there's hydraulic cylinders there, it's controlling the stabilisers as they come out. It allows the captain decision to press a button and essentially be more stable and go through a storm, or maybe have them in a different position and go faster around a storm. Rudder control, jet propulsion, propeller pitch. We've worked with customers who actually selected our triple redundant transducer for the pitch control. And sorry, I've not got a sample here today, but the triple redundant is literally 3 electronics heads and 3 separate waveguides in the transducer itself. So the customer will wire up all 3 outputs to be absolutely secure against any sort of problems. So if you really want a fit and forget device, which might be on some sort of rudder control like this, it might be inaccessible to get and change the device. Then the actual automation on the ship itself, turbine access systems we talked about before, compensating against the roll of the waves. And handling and automation on ships. And so the graphic doesn't really do justice to some of the projects which are out there and we've been involved with as well. But there's massive automation on probably images up on the poster on the wall of pipe handling systems, cable laying systems off the back of vessels, and there's a massive amount of complex hydraulic automation where definitely position feedback is needed. Civil engineering projects, lifting bridges, lock gates, tidal barriers, position sensors all around needed for this. Again, personally, some of the projects that Balluff have been involved in, we often seem to select this product now if it's out. We sort of call it our weatherproof device. It'll actually it's actually capable of doing 40 metres underwater, but it's the same technology inside. It's just a welded housing, and with this sort of conduit gland, we can do a proper termination over the top, and then make this IP69K, and essentially it can be underwater permanently up to 40 metres. Mining applications, the image you just saw representing the tunnelling equipment. My colleagues in Balluff, China, getting involved in lots of projects in tunnelling. Long hole drilling, again a project we were selected on was because of vibration, but we also did modifications to pot up the inside of the electronics to even protect it even further. I think we mentioned flight simulators before. And the last application I just want to mention, we've got involved in, again, the customer picked the triple redundant transducer. but for high-speed trains. So we actively tilt the train by 8 degrees so we can power in even faster into the corner. And finally, just a quick slide of our new customer showroom. We're based up in Cheshire. We moved there a year ago. We have lots of events there. We're proud to be hosting the NFPC meeting that's taking place in September. And we do lots of events, so there's a customer showroom there. You're all welcome to come and have a look. If you ever want to talk to us about anything, we do lots of training as well at these places for our customers, for staff, but lots of training events from maintenance level up to some of our industrial field bus products. Thank you.